SwayamPrabha. Digital India. Educated India.
Welcome back. So in the last class what we covered the robot anatomy, where we saw different parts of the robot that actually make up a robot. Right, you saw 6 degree of freedom industrial robot with different actuators which was there. Right, overall it was a 6 degrees of freedom robot. It had a gripper, it has a controller with an emergency stop switch, some IO board with some safety features in it. Right, and it has wires which was sufficiently long, and then you saw it had a teach pendant with again some special features which were there. So you see, that was the robot all about. Is it all that makes a robot? Just having a hardware does not suffice it from being qualified for being an industrial robot. So what goes inside? There are many other features which are there. So that is what we are going to discuss as a part of the module introduction. Today I will be discussing on some technical features of industrial robot that actually characterizes this type of robot. Got it? So yes, and what all standards which are there, which actually is very, very important when you say yes, I am going to buy this robot. So what features you should look for? Okay, let us say you want to compare two different robots that you have procured, and then you want to compare them on some specific features. So yes, today we'll talk about all those stuffs. So yes, let us start. So today I'll be discussing on the highlights of international standard ISO 9946, that is manipulating industrial robots, so presentation of characteristics. This is the standard which actually defines different technical parameters which are to be there in a technical specification sheet which is provided by the manufacturer. Okay, and then I'll discuss on some of those characteristics in detail, how they are defined, how we should go for, let us say if it is an emergency stop switch, how it should look like, where it should be located, and many other things that we'll be discussing. Okay, so let us start with highlights of industrial robot. Yes, so yes, in this standard, basically it is a standard that says manipulating industrial robots, presentation of characteristics. In general, if somebody is very novice, any standard which are of this kind normally explains the scope of this standard at the beginning of this document, right? Interrelated references, basically. Interrelated references without defining those references, you cannot fully define this particular ISO as well. Like one of them may be vocabulary of industrial robots. Without understanding different vocabularies of industrial robots, you cannot define ISO 9946 or many other similar ISO standards. So various terminologies which are there, units that this ISO standard will be following, and finally the characteristics, some special characteristics which are necessary to define this type of industrial robot, right? So I'll be talking one by one on each of them. Okay, so it assists, this type of standard basically assists an end user, a customer, maybe a power plant user, maybe a manufacturing plant who are going to use this type of robot, or maybe simple academician like me who use it for general purpose, for teaching and other things, right? For welding and some training, some special kind of thing. So in order to understand what this robot is going to give me, right? If I buy this, what all features will I be getting out of it, right? I'll be able to compare why this robot, why not some other robot. Got it? So if you have 2, 3 similar robots in hand, which one suits my particular application well, right? So I have to compare. Anybody has to compare for any particular application, even if it is for teaching. Sometimes, if not anything, at least cost is there. That is something which is beyond the standards, definitely, but beyond anything which is defined in a standard. But yes, it is to be compared as well. So yes, and then select various types of robot based on them, right? So normative references which are there, without which this particular ISO is not complete, is manipulating industrial robot vocabulary. That is a common industrial standard, ISO standard A8373 it is. Okay, so that defines various vocabulary that is commonly used in manipulating industrial robot. What is manipulating industrial robot is basically any robot that is able to manipulate an object in an industry, which can do pick and place of parts from one place to other, right? While doing so, it can even drag an electrode over a surface and do some welding work. That also is a manipulating robot. Yes, so all that finds its place in this. So another very important one is manipulating industrial robots performance criteria and test method. If I say my robot is repeatable, let's say it has a repeatability of 0.1 mm, so how it is tested? Those specific test techniques are covered in this ISO 9283. And if you say my robot can carry so much so of payload, so all those, how to define a payload and these special definitions is covered in this type of ISO standard. This particular standard basically covers all of them. So ISO 9409 is for manipulating industrial robot, again mechanical interfaces. Let's say this robot has a flange and now I want to fit up a gripper on top of it. Okay, so if at all there is a gripper, so that should fit on top of your end effector flange. So both the flanges should have same dimension so that you can fit different screws on top of it without any failure, without any subsequent modification of your finger or a gripper or anything. Right? That is a standard which precisely defines the placement of a flange on top of a robot so that any further attachments can be added very easily. So this mechanical interfaces basically defines that. It is defined in 9409. We'll talk about this even more in detail when we'll talk about interfaces in detail. Okay, ISO 9787, that again defines the coordinate systems, motion nomenclature. Right, these special terminologies are explained in this particular ISO standard, and that is very, very important to define this ISO 9946 as well. And definitely safety. This is ISO 10218, manipulating industrial robot safety. Safety is a subset of almost all the industrial standards. So that is mostly the part of each and every chapter of any ISO standard. Each and every part of a technical manual you will find a specific safety standards are mentioned. Okay, so yes, manufacturers they are bound to provide, if they are providing a robot, they are selling a robot. So if they have to sell this robot to international platform, definitely they shall provide all this. They have to qualify ISO 9946, which says they have to provide application where what is the intention, why you have made this robot, first of all, where you have planned this robot to go for. Let's say, is this robot fit for painting, vending, assembly? What is the probable application? Where do you seek this robot to go? Right? So that should be defined in by the manufacturer in its manual also. Sometimes robot name itself says, let's say KUKA KR5 ARC robot. The name itself says ARC. So mostly, although it can do pick and place if you put a gripper on top of it, but it is designed mostly to do arc welding applications. Sometimes the name says so, sometimes it is detailed in the data sheet also. Yes. So, and the power source. Power source means it is electrically actuated robot or hydraulically or a pneumatic one. We'll discuss about them in classification as well. So yes, power source is very important parameter which is to be defined also. So structure of the robot, whether it is a gantry type of robot or a cylindrical robot or a polar coordinated system robot or a standard articulated arm robot. Okay, that is very common in the industry. So these are some of the very special things which I won't be covering very much in detail now. Definitely I'll be covering in a different section of this module, which is classification of industrial robot. Oh, okay. So yes. So now robots shall also comply with ISO 10218, that is the safety standard that is defined here also. Okay. That is defined very much over here, you can see, yes. So that also defines stopping distance. Let's say if at all you have applied a brake, yes, how far it will further go, how much it is going to overshoot. A stopping distance is given, emergency stop switches, their requirement is given. Various other safety factors are defined in this ISO 10218. Okay. So now any deviation, if at all it is there from the related standard, that also needs to be stated by the manufacturer of the robot in their technical specification sheet. Okay, so this is all given in your standard ISO 9946. Let us now start defining one by one different special parameters which is always there in a robot technical specification sheet, and that is what anybody will seek for. Those are known as characteristics of the robot that basically characterizes the industrial robot. Okay. So yes, let us start with the first one in the queue, that is payload of a robot. It is the maximum weight that a robot can lift in all possible configuration. Like the down below you see there is one figure, a robot is something like this. Okay. As in the second figure you see it is little bit down, again further down, right, and then it is in a different position. There are a number of positions. So all the configuration that includes position in space and orientation in space. So in all those configuration, the robot should be able to pick up at least this much of load. This is what is the payload of the robot. Got it? So this includes the weight of the end effector tool. So when a robot comes, it comes barehanded, right? End effector tool is not mounted on the top of the robot. So if I say my robot can carry 12 kg payload, what my robot is, Yashikawa GP12, the video of which you saw in the last class. So you see it was 12 kg payload rated. Okay, that means without the gripper it is 12 kg. Gripper itself is, let's say, 2 kgs. Then the final payload that it can carry is remaining 10 kgs. Got it? So overall the payload which is specified by the manufacturer, they exclude that. So whatever is the payload that I am going to carry also includes the payload, that is your gripper itself becomes the payload for that kind of robot or any robot. Okay. So yes, industrial robots are certified for various performance characteristics, performance parameters like repeatability. If you say my robot is repeatable by 0.01 mm, okay, so 0.01 mm, so n number of times the robot can go there without deviating more than 0.01 mm. That means that particular repeatability is defined when the robot is already carrying at least 12 kg, at least the payload which is specified in the manual. Okay, so that much of load it will take up, and then it is supposed to do all those acrobatics. Okay, so if it says I can go, let us say, at 2 meters per second, it has to carry that 12 kg or that payload capacity of the robot and then it should be capable of moving at 2 meters per second. And if it says it can stop at so much of stopping distance, so if you apply with that payload brake on that robot, a robot should be stiff enough to stop immediately without further overshooting beyond the repeatable limits or whatever is the limits which is defined in your manual. Okay, so there are some specific standards which is defined as per the standard. There are some special specifications also which even manufacturers they are specifying in their manual. Though those are proprietary standards that they are always defining. Okay, so this is what is the payload. Second very important parameter is this. What you see here, one of the arm has got a load which is carried on its. So this is your base. Okay, then your first link, your second link, and so on and so forth. So you have further links. So one of the link can carry a payload which is other than what it was carrying somewhere over here. Okay, so this is the payload. This is the gripper other than payload. Obviously, payload is apart from this. Okay, so this is the load which is already there on the robot. So this is an additional. This is an additional load which can be mounted on one of the link. Like sometimes for this particular robot, when I use this one, this had a solenoid valve. Solenoid valve that used to operate this gripper, because this is a pneumatic gripper. To operate that through electrical actuation, it needs a directional control valve or flow control valve which can make this gripper open and close. So that is mounted within this box. So where this box is to be mounted, this should go not very remotely at some other location. So those are mounted sometimes on top of the robot, and one of the robot is sometimes made to do that. Okay, so robot controller is designed so as to take up that much of uncertainty in the load in that particular arm. Okay, so this is the location of this is defined. Even the maximum weight that can go on top of this supplementary load, that is also defined. So that location as well as the maximum weight is defined. It is an additional load apart from the robot's payload that it can carry in one of the link of the robot. Okay, the maximum dimensions and the possible position of the installation can be found in the data sheet. Okay. Now, robot axis. So what you see here is basically 3 different kinds of robot. Each one of them has different number of axes. It is basically the number of degrees of freedom for a typical industrial serial robot. So we'll talk about degrees of freedom very much in detail when we'll be discussing kinematics of the robot. For now, at least for a serial robot arm, normally number of independent joints it has, that becomes the number of axes for the robot, and that is the degree of freedom for that particular robot. That is in general not always true, but yes, that should be the case normally. Okay, as long as you don't have 2 different axes in the same axis, same direction. Okay, same they should, both the axes should not be collinear, let's say. Okay, until unless that is the case, this is normally true. So this is first of them. Let's say this is one robot where this is first axis, second axis, and this is third axis. So all 3 are rotation kind. Okay, these are rotational axes. One of them is prismatic axis. So this spindle can go up and down. Okay, this spindle can go up and down also. Got it? So this is a 4 degree of freedom robot when you have 3 rotational axes and one of them can go up and down. So that is SCARA. Okay, we'll do forward and inverse kinematics of this also. Okay, so this is a number of axes. Another one over here that you see is 6 degree of freedom robot. Okay, 6 degree of freedom robot, that is articulated arm robot. That is Fanuc R2000 IC robot. It is a 2000 kg payload capacity or more. So that is just a series name which Fanuc names it like this. Okay, so that is a robot which is 6 degree of freedom articulated arm. And next one is a 7 degree of freedom Kuka Aiwa. That's a 7-axis robot. First one is like this, next like this, this, and finally this. So 1, 2, 3, 4, 5, 6, 7. So 7 different axes are there. Okay, and it can go in a straight line vertically upward. So all the axes can be coaxial. Okay, it is designed like that. Okay, so this is a number of axes that is to be defined by the manufacturer in their manual also. Okay. Okay, so yes, that is number of axes. Now this is ISO 9409 that I was talking about earlier. So it is normally a standard media flange. Media flange means where you have to attach, that is the end effector flange of the robot, that is this one, okay, this one, where my gripper has to be fitted. Okay, I showed you fitting a gripper when I was demonstrating industrial serial robot in my lab in your first anatomy class. Okay, so I made a 2-fingered gripper fitting on top of this. Okay, so this is the flange where you see it has different holes over here. Okay, so on which you can screw your gripper. Okay, so this is the standard which is defined by ISO 9409. So why is this so important? Because this supports interchangeability of various end effector tools. Let's say today you have a 2-fingered gripper, tomorrow you may have a spot welding gun that can be fitted on top of it. So each one of them, although they have different shape after the flange, but the flange should be such that it should be fitting on top of this particular flange. Okay, so interchangeability is possible. Okay, so they have to follow all this standard, especially ISO 9409. While defining they cannot have a proprietary standard for the flange so that only Yaskawa can design a 2-fingered gripper which will go on top of it. So you can pick up a jammer, you can fit up ATI Shunk tool changer, you can fit even genetics or any other make 2-fingered gripper on top of this. Okay, so you got my point, what I am trying to say. Yes, so then a very important parameter which is defining the performance characteristics of industrial robot, that is ISO 9283. It is that defines also a parameter which is known as pose repeatability. This quantifies the differences which occur between the commanded position and the attained position. Okay, and the fluctuations in attained poses for a series of repeated visits to the commanded pose. Okay, what does it mean basically? Geometrically, let's say you want your robot to go to a specific place. Okay, you have commanded it to go there. Okay, now robot, whenever you command it to go there, it goes here, it goes here, it goes here. So every attempt it goes somewhere near to this particular point. Okay, now what happens? So this ISO standard basically defines the radius of the smallest sphere that encompasses all the positions reached for the same commanded position. Right, as long I have commanded it to go to, let's say, this red one, but it is going to the blue one, and this is the final circle. Oh sorry, it is, if it is in a 3 dimension, it has to be sphere. So this is the sphere that contains all the points, deviated points. I have commanded it to go to the red one, it goes all the blue. Okay, sometimes obviously it will go to the red one also. So the smallest sphere that can enclose all of them, so it is the radius of that. Okay, there are techniques to measure it also. There are different techniques to measure this also. So that is pose repeatability. Okay. Okay. So now ISO 9283 not just defines what is repeatability, it also defines the measurement procedure, how to measure repeatability. Okay, there is a huge set of procedure. What should be the environmental condition, what should be the maximum vibration all around, what should be the environment temperature, right? And what should be the payload which this robot should be carrying, while what should be the probe dimension, right? So each and every stuff is given in ISO 9283 when it says your robot is defined for so much so repeatability, okay? So it is measured with a specified payload, right? Definitely the payload is always there on top of the robot when ISO standard that repeatability is getting calculated, okay, or estimated through set of experiments. Maximum velocity under standard operating conditions as prescribed by the manufacturer, okay. So if manufacturer says maximum velocity is 1 meter per second, so repeatability should be measured with considering this velocity in while doing that experiments, right? So yes, for industrial robot, it varies somewhere between 0.05 mm so far what I have used to plus minus 0.1 mm. So you can imagine how stiff these robots are. So how the controllers are. Let's say a robot which is of 1 ton capacity or 2 ton like Fanuc, this type of robot, it is carrying 2 ton of payload and it is moving with 1 meter per second. So huge lot of momentum is there, and when you apply brake, your repeatability, while you command to go for a particular position, it should not overshoot beyond 0.1 mm. So you can imagine how good the controllers are for these kind of robots. So that is the reason these robots are hugely expensive. Not just the cost to make it, rather to go for all these testing, to make your robot qualified to undergo these kinds of tests, to get these certifications done, to qualify your robot to pass through all these tests so that you can fit well and compete well with other robots in the industry, right? So that is where the cost is, okay. So this is it. And then other parameters which are also defined in ISO 9283 is how much is the drift. Over, let's say I have commanded it to go to a place, it has gone there, right? Okay, with certain repeatability. How long can it retain there? With changes in temperature, can it start drifting? Okay, over period of time, is it stable there or not? Okay, how much is the overshoot while it was going there? How much is the accuracy? Stabilization time. Okay, what was the velocity, compliance, concerning deviations, all this is defined in this ISO standard, and repeatability is one of the major factor while selecting any robot, okay, because most of the industrial tasks are highly repeatable in nature. 24/7, 365 days, it keeps on doing almost the same stuff, right? So it should not deviate over the period of time. So yes, that guarantee should be given by the manufacturer, okay. So yes, one more very important parameter nowadays, at least in a modern shop floor, you will find robot is not just mounted on the floor. In the video application video also you saw some of the robots were mounted on the ground where it was picking huge objects and assembling the car body. One of them was hanging upside down and it was picking the top portion of the car and putting it from the top. It can be fitted on the side walls on a rail. It can be inclined and it can be fitted. So mounting position is also defined in the robot specification sheet or technical data sheet, which I say. Okay, so that is very, very important parameter. And this is the working envelope. Okay, for articulated arm, it looks like this. This is the working envelope is the all the poses, all the locations where your robot can go in all possible orientation. If you can go to any XYZ, you can orient any way you want. Okay, so that is the reason you see your tip, however, can go till here, but the envelope is only till here. Why? Because if you go here, you cannot orient anyhow you feel like. Got it? So that is very, very important parameter. All the locations are not included when you say your robot can go till here. You always show till here. Why? Because that becomes the working envelope of the robot. So why? Because if you can go here, yes, you can go there, that is something you can touch, but you cannot maybe hold that particular thing. Okay, any object which is kept here, you cannot orient it in a way where you can hold it actually. So that doesn't form the workspace of your robot, right? So this is the envelope, and that is, then there is some excluded spaces, that is also the inner boundaries. So this space your robot cannot go, right? So the workspace which working envelope for your robot, if it is an articulated arm robot, is something like this, which is very complicated in three-dimensional space. Okay, it has an outer boundary, it has an inner boundary, and sometimes within the space also the robot can go singular. So you may not be able to program your robot for that particular region, but there are different ways you can bypass them. So mostly your robot will include the inner boundary and the outer boundary. Whole of the boundary your robot can go. So yes, you have something which is a cylindrical workspace for a cylindrical robot, Cartesian workspace for a gantry type of robot, spherical workspace is there for a spherical robot. Articulated arm robot are very, very complex, like this one. Okay, it is having multiple convex surfaces which are there. Okay, and then you have convex surfaces like this, and then yes, it also shows the maximum reach where your robot can go. Again, you see, it is for maximum reach, definitely it is the flange which is at the maximum distance. Okay, so that is also given, but that is not the working envelope. Working envelope is not there. That is the maximum reach where your tip can go. Okay, sometimes that is extended beyond by adding a gripper. You sometimes are able to reach to a place which is further more than your maximum reach. Okay, so that is what is working envelope. And then other important parameters which are also there in the data sheet. One of very important parameter is ingress protection. You always are bounded by the type of application you are in. You want your robot to put it in. Let's say you want to do painting job, you want to do some spray painting job, right? So there is some ingress protection your robot should be on, right? Because your robot is mostly, industrial robots in particular, are made up of all electrical actuators. Even sensors are electrical in nature. So IP basically defines the type of electrical enclosure. Okay, it refers to the level of protection which is offered by any enclosure which is there. If it is a motor, that enclosure is actually of this IP class, ingress protection class, and that is defined by a standard which is known as ISO 20653 or DIN standard. English is 60529. These are IP codes. Okay, this refers to two specific digits. Okay, first digit is for solid, different shape, size of solid, and second digit is for liquids. Let's say, for example, if IP is 65, if you say my robot is of IP 65 class, it would mean the robot is totally protected against dust. Dust comes under the 6th number. Okay, I'll show you that particular table. Okay, it is this one. Okay, you see dust comes in the 6th one. Earlier one is the, you cannot insert hand, you cannot insert finger, you cannot insert any pointed object. Ultimately it is the dust. Okay, dust is the last one, that is 6th class, and protected against the low pressure jet of water from all the direction. That is the second letter of the IP class. What is 5? 5 is for water from, jet of water from all the direction. If it is more, 66, yes, it can withstand some sort of immersed, this equipment can be immersed within the water, and further it can be immersed to a significant depth within the water. It can be a spray of water, which is in a higher up category. Okay, so these two letters actually define the IP code. That is the ingress protection code. So this actually is very much required for selecting your robot for various applications. Your environment may be very dirty. Let's say you want your application, your robot to get into the mines. Definitely it should be protected for the dust. Okay, if it is to be outside environment, so it should handle at least a low pressure jet of water from all the direction, because it may have to bear rainfall at times. Okay, so yes, that is what. And then sound level. Different robots work with different sound, maximum sound it can generate depending on the application, right? So normally for industrial robot it lies somewhere between 60 to 80 decibels for industrial robot, which is very, very good. If you say sometimes it is in the range of 60 to 80 decibels, but for special applications like medical and all, that requires your robot to be below 40 decibels. Below 40 decibels. So there are a special class of robots that is defined by the manufacturer, which are tested to give you less noise, and those are suitable for that particular application like medical and all. Okay. For domestic application, it should be below 60 decibels. It is considered safe for human. For if you continuously hear that type of sound for longer amount of time, you go mad, no? Yes. For medical robots, less than 40 decibels. Okay, so working environment, other parameters are working environment like humidity, temperature. So what is the range of 0 to 70 degrees or minus 10 to plus 80 degrees. So that becomes the range where your robot can operate. If it goes beyond, so you cannot be assured that your robot will work the way it is defined by the manufacturer. Let's say I have defined it to work continuously for 24/7, maybe with temperature which is existing. Let's say if it is summer, you are going up to very high temperature of the surrounding, plus the controller can take up even higher temperature. So your robot may fail to give you the required performance which is defined in the data sheet. Humidity, sometimes in the sea weather condition, humidity can go more than 95%. Okay, so in those places maybe your robot is not suitable to work with. Okay, your controller, all the electronics may fail. Okay, so that environment condition is also stated in the robot specification sheet. Footprint area, that is very, very important, millimeter by millimeter normally it is mentioned in. So that is the bare minimum space where you can mount your robot. It is the footprint. Okay, it's the robot's demands against the requirement. So if you require this robot, okay, if it is of 1000 kg payload, I am going to be of this much size, and you have to give me at least this much of space so that I can fit in. Okay. Okay, so overall weight of the robot. This was the case when I was selecting at least one of my robot which was to be mounted on a lab which is at the 3rd floor. Okay, that was to be mounted on the 3rd floor. So I was very much cautious whether my ceiling is going to take up that much of load, at least the dynamic load. Dynamic is not mentioned in the robot data sheet. So at least the static load of the robot should be well known, and that is also defined in the robot data sheet. Okay, so this is one of the concern normally. Let's say you are going to mount a robot on a boat, right? That will become, the robot itself will become a payload for the boat. Okay, let's say you are going to mount a parallel robot on top of a serial robot. So parallel robot weight itself becomes the payload for that kind of serial robot. So weight of the robot is, that is the reason it is defined, although most of the time they are grouted to the ground and that can take a huge amount of load. But higher is the weight of the robot, normally they have a huge inertia. Okay, but if at all they say I can go at 2 meters per second, all the performance characteristics are well defined, it fits your limits, weight doesn't matter much. Okay. Other parameter, proprietary. There are some proprietary specification also, at least for the controller. Each and every part that fits on top of this robot also has this many parameters. Like IP, at least that is mentioned in the data sheet. Sound level is given, environmental condition. So not just the robot should handle all these conditions, even the gripper should be of this much condition. If a robot says I am of IP65 class, but my gripper is not. So what's the point? Definitely, ultimately, if you handle those kind of environment, it is going to fail. At least your gripper will fail. If your gripper fails or your tool fails, your robot has failed totally. Got it? So each and every thing that you are going to mount on this robot should qualify for that. Controller, maybe you can put it quite remotely off the robot location, but at least teach pendant, wrist, gripper, these things go directly on top of the robot and they should also qualify. So that is the reason some proprietary specifications are also given, at least for the controller, teach pendant, wrist which is there. So if at all you are going to mount this robot on a C environment, at least you can ensure that your controller and teach pendant is safe. They are kept out of that environment. Got it? Additionally, attachments like grippers, and yes, just now I have told, gripper sensors each have their own detailed technical, just see, detailed technical specification as in technical data sheet. So I'll be discussing some of the real technical data sheet now. Okay, so before to that, just see one of the additional parameter which is also there. So that is access data. Okay, as I told, one of the ISO standards covers number of accesses. They also should specify the extents and shape of the working. If it is a prismatic one, it can travel some linear distance, that is to be given. If it is an axis, plus minus how much degrees it can turn. Shape of the, this basically governs the shape of the working envelope which this robot is going to make. Okay, so that is the axis data. Plus and minus direction also is given. So you see, for axis 2 at least, this is the positive, negative direction, this is the positive direction. Okay, so while programming you should be very careful whether I am rotating in plus or minus direction, clockwise or counterclockwise. For each of the direction, each of the axis, this direction is also mentioned. And how many, let's say if it is a last tool, it can turn for, let's say, 3 turns or 4 turns or maybe infinite number of turns it can do. So that also is given. Okay, so that is very important. Okay, so it defines the positive direction, useful in programming mostly, and it is useful in identifying the safe zone from the link collision. So one can define the software limits on these axes. One of the axes, let's say if it moves by this much angle, it is going to cause some collision somewhere in the working environment. So you can definitely make sure by putting the software limits in the robot teach pendant or somewhere which manufacturer allows, you won't allow your robot to go beyond that, so that you can be very safe, very sure that yes, even if I go haywire, my robot is pretty safe. It is not going to collide anywhere. Okay. So I'll now discuss on some of the robot data sheet, and I'll show you one of the template data sheet also. Just be with me now, I'll show you. Yes. Okay, let us start with my own specifications that I prepared while tendering for my own robot which I wanted to buy. I just cannot say yes, I want to buy Yaskawa or Kuka or Fanuc or any make robot. So what I can specify maximum is the specification that I want, and I can mention the ISO standard which it should qualify to do that. If it claims I am so much so repeatable, as per ISO 9283, that qualification should be tested. Okay, and if required, they should be able to provide me with my all the test certificates. Okay, so that performance should be guaranteed based on that. Okay, so you see what all parameters that I have just taught you. Okay, so the payload, I wanted my robot to be almost up to 10 kg payload, because I wanted my robot to be used for doing some sort of welding operation, and I know welding electrode and the attachment and all can be fitted if it is beyond 10 kgs or something. So anything beyond 10 kgs, should be quite good enough. And I want my students to feel actual robots, so I want it to be really tall enough to look like an industrial robot at least. So I choose it to be something around 1400 mm. 6 degrees of freedom, because I want my robot to position and orient fully, so that I can teach full forward and inverse kinematics. So that was the reason for me. Maybe some other reason for a different user of it. If it is a painting application, mostly you need 6 degrees of freedom robot, but not for a pick and place task where a SCARA can go very well. Okay, so pose repeatability 0.08 mm or less is quite good enough. Sometimes it is more the better, like for payload. Not always true, but yes, at least for payload, more is better. At least for precision, repeatability, the less is better. Okay, but obviously they will have toll in the cost also. Protection rating should be IP54, but for the end effector, sometimes few robot manufacturers, they give you good protection rating for the IP54 for the motors, rest of the body of the robot, but when it says it is wrist, it is IP65, that is of higher class, because it is wrist that gets into the system, very much into the system, okay, that handles the task. That should be more rugged as compared to rest of the robot, as compared to different parts of the robot. Your wrist should be more stronger. They should be sustaining more dust, more water and those things. Sound levels should be, at least for industrial robot, because I was selecting, I chose it to be well below 70 decibel, which even my compressor, which was driving the pneumatic actuator, it was almost around 70 decibel. So okay, 70 decibel is quite good enough. I can shout in my class on my students even with this much of noise continuously on. Okay, so that day while demonstrating the robot, that recording also you can hear that noise which was running in the background. I intentionally didn't switch off that noise over there. So this robot, I wanted it to be fitted at least to the floor, to the ceiling, to the wall. This much capable robot, there are special feature. So I wanted, although I was sure I am going to mount it at least on the floor only. I am not going to mount it on the ceiling. But someday, who knows, I can mount it on the ceiling also. So yes, when I buy it, is not a everyday stuff. I bought it for all this. Footprint 700 by 700 mm. So that was the space which I was left with. So yes, all these parameters, I know in summers in my location it goes up to 45 degrees. So at least this much it should sustain. Okay, if it is somewhere in the extremely in the equatorial region, it can go beyond 50 degree. You can specify that. Humidity is non-condensing 95 degrees. Okay, non-condensing 95 degree. That is something very different. Normally, if it is 95% humidity, okay, it is quite okay. Robot can withstand. But with 95% humidity, if at all it starts condensing, maybe due to the surrounding temperature or maybe the controller temperature which is there inside, it starts precipitating, then what happens? 95% sounds very high for that. Got it? So in that cases, to withstand against that, I said okay, non-condensing 95%. Total weight, again I am placing this robot on the second floor this time, and it was placed on a cantilever which was, it was placed on a beam which was below to the ceiling. Okay, I could find out. So I want it not go beyond some 300 kg. That is safe limit which I could see. Although it can withstand, you are not very sure, it is lower the safer. So 300 is quite safe for most of the roofs that you see. So separate controller, I don't want controller and the robot to be mounted on the same place. Okay, so that I can keep my controller, which normally has some electronic components, to be little far off from my robot. So that is the reason I want it to be separate. So every user has their own requirement. This is not a necessary requirement sometimes, and it is not always defined in a ISO standard as well. So yes, it can be on the robot, it can be separate also. End effector normally should be this speed. See, range of access I have mentioned. Automatic. Operating system can be any Windows, Linux, proprietary or anything. Open architecture, this is one of the very special thing that I have put. My architecture should be open so that I can fit any IO cards, any input and output card. Not necessarily if it is a Yaskawa robot, I should be able to put only Yaskawa thing. So controller is of open architecture. I can put any Profibus, EtherCAT or any sort of communication to interface with any IO system, although it had already 16 input and output inbuilt to the system. But even if you sometimes want to have some sensor which is outside the controller, definitely you should have that. Okay. Additional keyboard, mouse, display. Sometimes for us at least, we are not always happy with the teach pendant. I at least prefer having a keyboard at least so that I can conveniently key in my robot programming sometimes. Mouse, easy to handle, the GUI which I can see. Sometimes an external display is very, very helpful. All these should be supported by industrial robot. It is not always true. Industry people, they don't think like that. They are happy with just the keyboard, just a teach pendant because they are used to it. It is very, very okay with this, and not always even the teach pendant. Once it is programmed, you forget about it. You need not to change every now and then. You should be happy with it. And they have dedicated operators who can handle things with just teach pendant. Okay, built-in servo drives, extension possible, 3-phase neutral and earthing connection. That is important. Sometimes if it is 2-phase 220 volt, single phase 220 volt, it is quite good enough. Warranty, these are some special things that you can ask for. Joystick, it should have a joystick or some sort of buttons to make your robot go to XYZ location, orientation and all. Okay, weight should be, if it is a teach pendant, it should be below 2 kg so that you can hold it firmly in your hand. Okay, one USB connection should be there so that I can put in my pen drive and externally offline programs I can put it in. Grippers, some standard grippers, I have named it here, Stump, Jimmer, Fisto, whatever is a 2-fingered gripper that can hold 2 kgs of payload, it should be good enough. Okay, maximum force, gripping force is mentioned. Workpiece, additional there are, and then there are many other things. This is the PC which I wanted to interface, so that is why it is here. So yes, this is one of the real data sheet which you can see. This is for Yaskawa GP12, my robot only. So this is the workspace which is given in the data sheet. You see, this is the working envelope. This is the working envelope, right? So this robot, this place, these are the places where it cannot go. Okay, and this is the places where it can go. You see, it's a complex shape all over. Okay, it is a complex shape. For different views it is given. So these are some of the parameters which I have just discussed. Controller axis, you see it is here. Payload is given. Maximum load it can carry. Repeatability is given. Plus minus axis angles are given. What are the angles for each of the joint it can go. Maximum speed of the joint is given here. Allowable moments which are here. Allowable moment of inertia which it can take up. Total weight of the robot is given. Weight, no, it says mass. Okay, and IP67 for the wrist, you see, and 54 for the rest of the body. It can operate with 0 to 45 degrees. Relative humidity is something around 80%. Non-condensing it can take, and vibration it cannot take more than this. And then these are not necessary parameters which are there, but may be very, very useful for some specific requirement. It requires at least this much of power. Electrical load rating is given, so that if you plug into a plug point, definitely it should be capable to carry at least this much of load, and it can be mounted on the floor, wall, ceiling, and it can even be tilted. Okay, so these are some of the parameters. Once you see it is specifying it is a hollow arm. It is a proprietary specification which is also given over here. It has a hollow arm. It may be required for arc welding robot because you have to pass through many cables from between, and if it is so, if it is hollow, it cable doesn't interfere. Okay, it simplifies teaching, and teaching the, not teaching my students, while teaching the robot, because you program a robot, while programming you do teaching and it repeats the task. Okay, so that is what is teaching. Eliminates cable disconnection. If it gets entangled to some object in the surrounding, the wire may be plugged out. Okay, in that case it should not interfere with the working of the robot. Okay, so yes, so this is one of the very important specification. Okay, and then let's say this is a KUKA robot, and I'll come directly. There are many other parameters which are given here. In today's lecture, I'll just cover the technical things. Technical data which is there. So this is number of axes. Working envelope, it shows it is in meter cube. It's a volume. Repeatability, again it says as per this certificate it is ISO 9283, it is 0.05 mm. Weight, got it? So all similar parameters you see they are here. Axis, ranges, their angular velocity, right? This is the axis data, plus minus, and the direction. Okay, and you see working envelope, how it can go, where it can go, right? And the payload for a different class altogether. So this is also there. So this is for another robot which is a Fanuc robot now. You see this again is a similar one. This time it also shows quite a lot of details which are not always required for anyone, but the details which are required, it is always there as specified by the ISO standard. So it has, you see it is in a tabulated manner. This is the coupling flange which I was talking about. So this is the flange dimension, that is the media flange where you can fit in your gripper or any other tool to work with. Okay, so this is the flange dimension which is given. This is as per the ISO standard. Okay, this is the repeatability and all the dimensions which I just discussed. So you see this is all about industrial robots, their technical specifications which is here. Got it? So now with this I think I would end today's lecture. Okay. So thanks a lot for being with me, and next class I'll be discussing the classification of industrial robot, why that is important, how different technical parameters are used to qualify a robot for a given class. We'll discuss everything in that class. Thanks a lot for being with me. That's all.